Hello again. Today I'm going to talk to you about something that's really quite important about Unix-based programs and C coding in general. And in fact, this has quite a bit more to do about C than it does about assembly. So this is a transition now from what we've been doing with assembly into thinking more about the main memory on our machine and how these programs use that memory. And we're going to see a different way of being able to use that memory today. So I'll actually be taking you through a little bit of the activity just to illustrate some of the points that you should get out of it. Okay, so now this is a picture that you're going to see again in some upcoming presentations that illustrates a portion of our computer. That is the CPU chip itself, and then the registers, which you've been learning a lot about, and this arithmetic logic unit is the thing that is the part of the CPU that executes the arithmetic expressions that you've been looking at. And then, of course, we have our main memory, and the CPU is connected to the main memory, and we're going to talk some more about that in some upcoming presentations. But one thing to notice is, when your program is running in main memory, we've talked a little bit about this, right? That it's over here running somewhere in main memory, and in Linux and Unix systems, it's been allocated some space in main memory. And that space looks something like this. So there is the portion here that's the instructions themselves that are being executed, and also any of the data. Some of the data might be constants that are read-only. Some of the data might be regular variables that you have declared in your code. And so those are all loaded into memory. Now there are other portions assigned to your program. So another one is, any of these shared libraries from the C language itself are mapped to a portion of your program's memory. The stack here is kind of interesting. This is where information for every function that you call gets stored temporarily. The thing that we're going to spend some time looking at now in this next activity, so every program has this structure. And the thing we're going to look at more carefully is this thing called the runtime heap. And so in this portion of memory, if we've declared an array to have a specific size statically, then it shows up here. What's nice about this thing called the runtime heap, which has nothing to do with heaps that you might have learned about in a data structures class, by the way, this is a portion of the memory that we can allocate at runtime by using a particular C function called malloc. And so this allows us to create an array 1D or 2D, and in the activity we're going to see a 1D array, on the fly at runtime with a particular size. So it lets us change the size of the array depending on what we need as our program is running. So this becomes a very effective technique in a lot of C programs. Now, it does have some issues in that you do need to deallocate this memory with a command called free, which we're going to see. And if you don't do that, you can run into some issues of this filling up. And this is a problem that's called a memory leak in a C program. If you keep filling up this heap and it doesn't, um, and it gets full. Um, and so we do have to worry about that, and it is a common uh, cause of errors in C programs. So we're going to look at this by um, looking at a new activity. So there's a new GitHub repo for you to clone. This is what it's called. And again, this is really more about C programming than it is assembly. So in fact, it's located in the next section on Moodle, which I'm going to demonstrate to you in a minute, show you exactly where it is so you can find it. And then the thing to notice here is that what we're going to do in this code is we're going to work with a 1D array. So we normally might have decided to declare that array this way. This is what we've seen in previous presentations and activities. But now what we're going to do is we're instead going to start by declaring an integer pointer a. And this pointer eventually will now point to the 0th element of the array, but it's going to be stored on the heap because we're going to use this function malloc here. So you notice we call malloc by giving it the length of the array times the size of an integer. So basically what malloc is doing is creating an array of bytes. But then by declaring it an int star out here, the code now knows this is an array of integers. And so this is what we have to get used to here. This is the new key idea, is that you've got to get used to how you can dynamically declare an array, and then you can use it as if you had declared it this way. But now it can be of different sizes, and we're going to see in the code how we can change this value and then declare that array to have a different size. And so this is the interesting point too. How do we do this? How do we get different sizes? And so I'm also going to show you something called how we get information from the command line in C. And this is a very important thing that as you go forward doing C coding, you really are going to need to know how to do. So that's shown in this particular activity as well. And so let's go ahead and have a look at this activity now. I'm just going to demonstrate its use and show you a couple more things in the code. Okay, so what I'm going to do here now is I'm going to switch over to, I'm using Visual Studio Code in this case. And so here is, I've already made my copy of the repo. Now that repo is shown here. So this is our Moodle page, what it looks like for you. And way down at the bottom now in part 3 is where the link to this activity is. And the slides that I just went through and additional slides going forward will be in this area of Moodle. Okay, so now as you, after you've made this, this new repo, you'll see that there's one C file and a makefile. And then there's the README, so I encourage you to go ahead and look at that and work your way through what I've said there in the README. I guess I can go ahead and put that up if we want. I'm going to open the preview here and put that over here to the side. Oops, that wasn't the one I wanted though. Let's get that over here, shall we? Ooh, I'm having fun, aren't I? Okay. Now I'm going to open up the Makefile so that we can see that. And so one thing to notice about this Makefile is that we're making not only an executable, but we're also making the assembly code. But the executable is the thing that we're going to focus more on. And at the end of the README, I show you that you could go in and look at the assembly code, which is starting to get quite a bit more complicated with a larger C file like this. This is the name of our executable that we're going to be able to run once we do the Makefile. So let's have a look at this C code for a moment here. And what you should notice first is that we are bringing in a new library called stdlib.h, and that has a couple of different functions that we're ending up using here. One called malloc and one called ATOI, which stands for ASCII to integer. So I'm going to show you the use of those down below so that you can see where those are. But one thing you should notice is that these couple of functions here, these first two functions, are the same as in a previous activity where you were working through every element of an array and summing them up. This little function here, I encourage you to go and have a look at and see what's going on. It's basically a way to check whether these functions above were working. So you can have a look at those. Let me point out the main things that are happening here. So one thing to notice is that we now are using something that's always been available to us in our main C code, but we haven't paid too much attention to. So I want to point this out to you. So C main functions, in addition to returning an int, can take these two arguments. The first is an integer. The second is an array of strings. And so this means that every time we type in the name of our function, we actually can send it different strings separated by spaces. And then the way C works is it'll take those, and those are called command line arguments, and that's why this is called argv. It's a vector of strings of arguments we might have sent to our code, and I'll demonstrate this in a minute. And so the idea here is that this argc indicates how many arguments you typed in after, and including actually the name of your program. And so if this argc is greater than 1, that means you always you had typed in at least one argument. In this case, what we're doing is argv0 is always the name of your program that you're running, and then argv1 is going to be the first arguments that is typed in. And so here what we're doing is we're taking that first argument and we're converting that string into an integer. You see here that the reason for this is that then we can use a variable length for the array that we're going to create. And then here's that code that I was showing you in the slides where we're creating a pointer to an int, which then becomes a pointer to the 0th element of an array of ints after we execute this malloc instruction here. And then so only after we've created the space can we then put values into that array. And this little loop fills that array with values from 0 to the array length -1. Then the functions to sum up those values are called here, and then the this scan sum is a way to sum up those very same values in a different way, and then assert that here we're asserting that the sump function actually worked correctly, and similarly sumindex does the very same thing. And then you'll notice here at the bottom, when we're done, we execute this free command, because once we've allocated our memory on the heap, we have to get rid of it. Otherwise, we have this issue of something that's called a memory leak. And so we always want to make sure that we have a corresponding free for every malloc we ever have in our code. This example, it's easy to see. In bigger code examples, it's harder to get this right all the time, and it's a classic source of errors in C. So now let me go ahead and get onto our server and show you this code executing so that you can see how it's going to work. So I'm going to do this. Let's see now. Here is our activity. So I've already put this over on the server. You'll have to do this. And so now I'm going to make, and you see it did make both the assembly version and then this actual executable version of the code. Now, if we run this by itself without any command line arguments, so this is just the name of the program being run here, the array length got set to 10, and that's up here at the top of the code. You'll see this default n, which was declared here using something called a #define. So that's how we get a default, and that in this case then argc was only 1, and so it didn't do this. But now if I run it again and I give it, say, a length of 20, you'll notice that it set the array length to 20, and now the sum of the elements is a bigger number. And so you can go ahead and see this for yourself and try bigger numbers yet. And you'll see that we are dynamically allocating on the heap then an array of whatever length we wish. And so this becomes a powerful way for us to run our code with varying sizes. And we probably are going to have some other examples of this in the future. So this is just something very good to know about C programming, that we can dynamically allocate space if we don't know how big our array should be at the time of compiling the program, and instead want to set up the lengths of our arrays based on user input. So go ahead and try this yourself, study this code carefully, read the README, and make sure that you understand it.